In algebra, the ability to factor an expression can be very useful in simplifying and solving equations and can help us easily find the x-intercepts of an equation algebraically. But before we go into all of that, I want to talk first just about what is it that we mean by factoring, breaking something into its factors. So a factor of an expression is just something that when you multiply it by another factor, it gives you that original expression. So it's just breaking something into multiplication. Okay, so let's just not even worry with variables for a minute. Let's just take a simple number like 18. Okay, so if we break this into its individual factors, what factors do you think of? Okay, well, I think of 2 times 9, right? Now, 9 also has some factors, right? So we could think of 9 as 3 times 3. Okay, so now what I've done here is I've broken 18 down into what we call its prime factorization. And of course, a prime number is a number that's only divisible by itself and 1, right? 2 and 3 are both prime numbers. Okay, now that's not the only thing you could have seen, right? You could have seen 3 and 6, right? 6 is 2 times 3. We still would have gotten down to this factorization. Now, to get at that prime factorization of a number, one way that I learned is to do a tree like this. So you have 2 times 9, and then with 9 you have 3 times 3. Um, that's a lot of trouble for something that's in the times table that you're kind of familiar with already, but it's certainly an option, right? And then the prime factorization are all of the ones right down here at the end of the trees. So let's take another one like 24. Okay, so 24, I think of 2 times 12. There's a lot of things you could think of, right? 4 times 6, 3 times 8, things like that. So, but with 2 times 12, then we could keep going, right? 2 times 12 is really 2 times 6, right? And then 6 is 2 times 3, right? So we have 2 times 2 times 2 times 3, right? Now, so with the prime factorization, notice any combination of these numbers, right? 2 times 2 is 4, and 2 times 3 is 6. So 4 times 6, that's also going to be in it. 2 times 2 times 2 is 8, right? And 8 times 3 is 24. So any combinations of these work. That's why the prime factorization is so useful. So let's go to 8x cubed here. So 8, I think of that as 2 times 4. And 4, of course, is 2 times 2. So 2 times 2 times 2. And we established over here when we were doing the factors of 24 that 8 times 3, right? 2 times 2 times 2. Okay, and then x cubed is just x times x times x, right? So breaking something down into its factors, we can think about it this way. Okay, so 15, I think of 3 times 5, right? 3 and 5 are both prime numbers. Okay, and then x, that's just by itself, and then we have y squared, right, which is y times y. So the ability to break something into its individual factors, both numbers and variables, is going to be really important as we go about learning various factoring techniques with polynomials.